Hello students, welcome to the third lecture on the lecture series on area perimeter of basic geometric figures. Okay, in the previous lecture we did some theory and we'll actually have to cover some more theory so that we could actually cover all the kind of geometric figures that we need to see for exam perspective. Okay, so let's start the lecture. So let's see about angles in a circle. Okay, so the angle subtended by an arc at the center is twice the angle subtended at the circumference. Okay, so basically if you are given an arc just like here, okay, so this is basically a circle. Okay, arc is a part of circle, right? So let's try to draw a circle first, then see an arc first. Okay, so here we have got a arc. Okay, so what happens is it tells us that the angle subtended by the arc at the center is twice. So this is basically twice the angle subtended at the circumference. Okay, whatever the angle is actually subtended by the circumference is actually twice the amount subtended by the arc at the center. Okay, so this angle is basically its half at the angle that is actually subtended at the circumference. Okay, so let's try to see the tangent properties. So a radius drawn to the point of tangency is perpendicular to the tangent line, right? So tangents drawn from an external point to a circle are congruent. So the lengths of the two tangent segments drawn from an external point to the circle are actually equal. Okay, so this is the external point, here P is the external point and S is the circle, O is the center, right? So we have drawn two tangents to point A and point B of the circle. Okay, so radius drawn to the point of tangency is actually perpendicular. So this tangent line is actually perpendicular to this radius line. Okay, so tangents drawn from an external point to the circle are actually congruent. So these two have same lengths. Okay, so the lengths of the two tangent segments drawn from an external point to a circle are actually equal. So let's try to see the next properties. So suppose that two tangents are drawn to the circle S from an exterior point P. Okay, here you have the exterior point P, and what happens is you draw two tangents at point A and B of the circle. So let the points of contact be A and B as shown. So the lengths of these two tangents will be equal, that is PA is equal to PB. Okay, so they will subtend equal angles at the center. Okay, so this angle is actually equal to this angle. So let's see what is second theorem. So two secant segments are drawn from same external points to a circle. The product of the lengths of the one secant segment and its external segment is actually equal to the product of lengths of the other secant segment and its external segment. Okay, so this is the second segment. Okay, so product of these two is actually equal to product of these two, that is DC into PC is actually equal to PA into PB. Okay, that is what second theorem tells us. Okay, so this is the pictorial view. So let's try to see the next property. Okay, so the next property is intersecting chords theorem. Okay, so if two chords intersect inside a circle, okay, here as you can see that this is a chord and this is also another chord. Okay, so these two actually intersect. So the product of the segments of one chord is equal to product of the segments of the other chord. Okay, so as you can see here, so we have two chords here and two arc here. Okay, so these two chords are intersecting, right? So this, that is C part. Okay, this chords C part and D part, their product is actually equal to A part and B part of the next chord. Okay, so let's try to see what is alternate segment theorem is. Okay, so the angle between a tangent and a chord through the point of contact is equal to the angle in the alternate segment. Okay, so this angle is actually equal to this angle if the black line is actually parallel to the pink line. Okay, and it is drawn at the vertex of that triangle. If that is true, then this is also true. Okay, so let's try to see the kind of property that is about parallelogram. Okay, so how we can actually evaluate the area of a parallelogram. So we have now concluded circle. So now let's see how can we evaluate the area of a parallelogram. So area of a parallelogram is nothing but area is equal to B into H. So what is H here? So H is the height, that is the distance from this point to this point. Okay, that is what height is of a parallelogram, and base is the length of the largest side. Okay, the side at which the height has been drawn to. Okay, so what is perimeter of a Parallelogram. So the perimeter of a parallelogram is found by adding the lengths of four sides. Okay. So since all the opposite sides are actually equal, but only opposite angles are equal, not all angles are actually 90 degree or any kind of idea we have. Only we have idea that two angles must be greater than 90 degree and two angles must be less than 90 degree. Okay. So perimeter of a parallelogram will be 2 into a plus b, where a and b are length of the sides. Okay, distinct sides. So let's try to evaluate a formula to get the diagonal lengths of a parallelogram. So if P is the diagonal, okay, then P is equal to a square plus b square minus 2ab cos a. Okay, this will be the formula for the diagonal. Okay, that is actually equal to what? A square plus b square plus 2ab into cos b. Okay, and Q is equal to what? A square plus b square plus 2ab cos a. That is actually equal to a square plus b square minus 2ab cos b. Okay, so basically p square plus q square is equal to 2 into a square plus b square. Okay, so let's try to see what is a polygon is. So let's start with the definition. So a polygon is a closed plane figure formed by three or more line segments called sides, such that each side intersects exactly two other sides. Okay, one at each of its endpoints. So no two sides with a common endpoint overlap except at the endpoint. Okay, so let's try to see what is polygon, what is interior and exterior angle, right? So interior angles of a polygon add up to n minus 2 into 180 degree, where n is the number of sides. Okay, so if it is a what? Quadrilateral, then there are how many gons are there? There are 4 gons. Okay, quadrilateral are also called 4 gons. So their angles will add up to what? Their angles will add up to 4 minus 2 into 180, that is equal to 360, and we know this is actually true. Okay, so the sum of the interior and exterior angles at any vertex of a polygon is always 180. So basically, if you have a polygon, okay, so whatever the other structure, the remaining structure is, let's try to see at this vertex point of the n-gon. Okay, so basically what we do is we stretch and expand this line segment. Okay, then what we do is we add these two angles. This will be always equal to 180 degree. Okay, so always the sum of interior and exterior angle at any vertex. So for this vertex, this is its exterior angle and this is its interior angle. So their sum will be always 180 degree. So let's try to see in a polygon what convex and concave polygons are. Okay, if all the interior angles of a polygon are less than 180 degree, the polygon is convex. If one or more of the interior angles is actually more than 180 degree, then the polygon is called concave. Okay, so when we say that a polygon is concave, when one or more of the interior angles is actually more than 180 degree, and when we say that the interior angles of a polygon are actually less than 180 degree, the polygon is convex. Okay, so all the interior angles less than 180 means convex and greater than 180 means concave. Okay, so let's try to see what a regular and irregular polygons are. So a polygon is regular if all its sides are actually of equal length and all the angles are of equal measure. Okay, so basically you have a polygon and what you see is it is actually regular if all the sides are equal length. Okay, all the sides are equal and all the angles are of equal measure. And when you say it is irregular, if any of one condition out of these two will fail, this implies that this won't be a regular polygon. This will be irregular polygon. Okay, so we have discussed regular and irregular polygon. What are regular and irregular polygons? So let's try to see. A diagonal is a line segment that joins two non-consecutive vertices of a polygon. Okay, so let's see if you have a 5-gon. Okay, so basically you have a 5-gon. So if I draw from this vertex to this vertex, okay, all I have to do is I don't have to draw it to consecutive vertices. Okay, then this is a diagonal, this is a diagonal, this is a diagonal. Okay, this is a diagonal. These are all diagonals. This is also a diagonal. This is also a diagonal. These are all diagonals of a 5-gon. Okay, so the number of diagonals in a polygon with n sides is given by n into n minus 3 by 2. Okay, this is the formula to get if we are given a n-gon, then how we can actually evaluate how many diagonals will be there. Okay, so there are 12 types of questions asked usually from this chapter. Okay, the first one is regarding finding area, and the second one is regarding finding perimeter, third one is on combined sets, then missing measurements, word problems, ratio and proportion. Okay, successive changes, diagonals and special points, circle and arcs, conversion problems, polygons, rhombus. Okay, so these are usually the questions that are usually being asked on various competitive exams. So let's start to do some among these in detail. Okay, so let's start a question on finding area. Find the area of the rectangle where length is 6 cm and width is 4. So 6 into 4 is equal to what? See, 24 centimeter square. So this will be equal to the area, right? So let's try to find the area of the rectangle. So it will be L into W, that is 24 centimeter square. So area of the rectangle is 24 centimeter square. So determine the perimeter of a square with side length 12. So it will be 12, 12, 12 and 12. Since all the sides have 12 centimeter as its length. Okay, it will be what? 12 into 4. That will be equal to 48 centimeter. Okay, so perimeter will be what? 4 into side length. So 12 into 4 is equal to 48. That is what given there. So let's try to see the third kind of question. Okay, that is on combined shapes. So find the total area of the composite figure shown below. Picture A. That is rectangle with dimension 6 into 10 centimeter and right angle with base 8 centimeter and height 4 centimeter on the top of the rectangle. Okay, so the total area will be what? So first we need to evaluate the area of this part. So it will be what? 10 into 6, that is equal to 60 centimeter square. Okay, then we need to evaluate the area of this part. That will be what? 1 by 2. And we need the value, we have the value of what? Height, it will be 4. And we have the value of base. Half into height into base is equal to the area of the triangle. It will be into 8, right? So this will be equal to 8 into 2 equal to 16 centimeter square. So adding these two, what we are left with is 76 centimeter square. Okay, so this will be the actually correct answer. Okay, so calculating the area of the rectangle, it will be length into breadth, that is 6 into 10 is equal to 60 centimeter square. So calculating the area of the right angle, so it will be half into base into height, so 1 by 2 into 8 into 4 is equal to 16 centimeter square. So adding these two, what we are left with is 76 centimeter square. So the total area of the composite figure is what? 76 centimeter square. So let's try to see the problem. The length of the rectangle is what? 12 centimeter and its area is 96 centimeter square. So find the width of the rectangle. Okay, so area is what? 96 centimeter square, where length is 12 centimeter. Okay, so given that length is equal to this much, area is this much, so how we can actually calculate the width or breadth? It will be what? Area by length. So area is 96 centimeter square and length is 12 centimeter, so width becomes 8 centimeter. Okay, so the solution for width is what? 8 centimeter. Let's try to see the fifth kind of problem, that is actually based on word problem. So Mr. Smith wants to lay tiles in his rectangular garden measuring 8 meters by 5 meters. Okay, so how many square meters of tiles does it need to cover the garden? So all we need to do is we need to calculate the area. It will be 8 into 5 is equal to 40 meters square. Okay, so 40 tiles needed. 40 tiles needed. Okay, given L is equal to this, that is 8 meters, width W is equal to 5 meters. So area is equal to length into width. So 8 meter into 5 meter is equal to 40 square meters. Okay, so Mr. Smith needs 40 square meters of tiles to cover his garden. Okay, so let's try to see a problem. So the sides of a rectangle are in the ratio 3:4 and its area is 252 centimeter square. Then find the length and width of the rectangle. Okay, so the sides of a rectangle are in the ratio of 3:4 and its area is what? 252 centimeter square. Then find the length and width of the rectangle. So step 1 is what? Given length is to width is equal to what? 3:4. That is area is equal to 252 centimeter square. So area will be what? 252 centimeter square, where width is 4x and length is 3x, right? So length is equal to 3x, width is equal to 4x. So 252 centimeter square is equal to nothing but 12x square. Okay, so x square will be what? X square is equal to 252 by 12, right? So it will be 6 and it will be 126. So it will be what? 63 by 3. That will be equal to 21. So 21 will be the answer for x square. Okay, so if x square is equal to this much, so x will be what? Square root of 21. Okay, x square is equal to this much, so x will be equal to 4.58 centimeter approximately. Okay, so step find is what? How we can actually evaluate 3x? By multiplying 4.58 with 3. And how we can evaluate 4x? That is 4 into square root of 21, that is equal to 18.32 centimeter. Okay, so these are actually the length and width respectively. Okay, for the given question. Okay, that is the sides of a rectangle are in the ratio of this and its area is this much. Then find the length and width of the rectangle. So length will be approximately what, 13.74 centimeter, and width will be 18.32 centimeter approximately. Okay, so let's try to see the seventh kind of question, that is on successive changes. Okay, so problem: the length of rectangle is increased by 20% and its worth is decreased by 10%. So if the original area was 120 centimeter square, then find the new area. Okay, given original area is equal to what, 120 centimeter square, increase in length is equal to 20%, decrease in width is equal to 10%, right? So step 2 is what, calculating the new length and width. So new length will be what, original length plus increase in length. Okay, that will be the new length. So original length plus 20% of original length, so it will be 1.2 into original length. So original width minus decrease in width, it will be equal to what, original width 0.9 into original width, because this step implies 0.9 into original width. So let's try to see step number 3. So calculate the new area using the new length and width. Okay, so new area is equal to new length into new width. So 1.20 into original length into 0.90 into original width, that will be equal to 1.08 into original area. Okay, so substitute the given value of original area. So new area is equal to 1.08 into 120 centimeter square, so 129.6 centimeter square. So the new area is what, 129.6 centimeter square. Okay, so let's try to solve the problem number 8, or the kind of problem that is actually asked in various competitive exams, that is on diagonals and special points. So in a square with side length this much, and find the length of the diagonal. Okay, so it will be what, root 2 into 6, right? So this will be equal to what, so root 2 into 6 will be equal to this much, that is 6.49. Also we can use this formula, that is the Pythagorean equation, that diagonal is equal to what, side length square into side length plus side length square. Okay, so length of the diagonal in the square is approximately 8.49 centimeter. So let's try to see the 9th kind of question, that is on circles and arcs. So find the area of the sector formed by central angle of 60 degrees in a circle with radius 7 centimeter. Okay, take pi is equal to 3.14. Find the area of the sector formed by central angle of 60 degree in a circle with radius 7 centimeter. Okay, take pi is equal to 3.14. Okay, so this will be equal to what, area of the sector is equal to theta by 360 into pi into r square, right? So theta is the central angle, pi is the constant 3.14, and r is the radius of the circle, that is 7 centimeter in this case. Okay, so area of the sector will be equal to 60 by 360 into 3.14 into 7 square. Okay, simplifying the fraction, what we are left with is 1 by 6 into 3.14 into 49. So area of the sector will be 25.64 centimeter square. So the area of the sector formed by a central angle of 60 degree in a circle with radius 7 centimeter is 25.64 centimeter square approximately. So a rectangular room is 5 meters long and 4 meters wide. Find its area in square centimeters. Okay, so length is equal to 5 meter, width is equal to 4 meters. So area will be equal to what, 2 lakh centimeter square. So the area of the room is 2 lakh square centimeter. Okay, that is what we have right now. So let's try to see the 11th kind of question, that is each interior angle of a polygon is 108 degree, and find the number of sides of the polygon. Okay, so one interior angle of the regular polygon is this much. So all the interior angles of the regular polygon are equal. So sum of interior angles of a regular polygon is n minus 2 into 180. Okay, because their sum must be equal to this much. So it will be equal to this much by n. So let's try to see if this much by n is equal to 108 degree. So 108n is equal to 108n, 180n minus 360. So solving this, what we are left with is 72n is equal to 360. So n is equal to 5 will be the answer. So let's try to see the 12th kind of question, that is on rhombus. Okay, one of the diagonals of a rhombus and its side are actually equal. Then find the angles of the rhombus. Okay, PQ is equal to QR is equal to RS is equal to PS is equal to PR. So PRS and PQ are all what, equilateral, right? So PQR and PRS. Okay, these are equilateral triangles. So S is equal to Q is equal to 60 degree. P is equal to angle 1 plus angle 2. Angle P is equal to angle 1 plus angle 2, that is equal to 60 plus 60 is equal to 120 is equal to angle of R. So hence S is equal to Q is equal to 60 degree measure, and angle of P is equal to angle of R is equal to 120 degree. Okay, so I believe that's enough for today. Thank you.